This ninth topic deals with solving trigonometric equations using identities. If we have a look at this example over here, this is essentially a quadratic equation. So we're going to follow the principles that we do with an algebraic quadratic equation. The principle, everything on one side equals naught, and then factorize. This first sum, our common factor is going to be sine of theta, and our bracket becomes sine theta minus 3 cos theta is equal to naught. When a product is equal to 0, it simply means that either one of those factors can be equal to 0. So sine theta will be equal to 3 cos theta, or sine theta will be equal to 0. Now if sine theta equals 3 cos theta, we want to get one trig ratio out of that. So remember, we're going to divide both sides by cos theta, because sine theta over cos theta is going to be tan theta. So essentially we're solving two trig equations, one of which says sine theta is equal to 0 and one which says tan theta equals 3. So if sine theta equals 0, we get theta is equal to 0 plus k360, or theta is equal to 180 minus 0 plus k360. If tan theta is equal to 3, arctan of 3 is going to be 71, let's just round it off to one decimal place. We're going to get that theta is equal to 71,6 degrees plus k180, and don't forget, every time you need to write down that k is an element of the set of integers. Right, now the second example over here, again it's quadratic, we've got a term that is squared. The trouble is here we've got a sine squared and we've got a cos theta. We need to get a trinomial out of that. I can't turn the cos into sine, but I can replace the sine squared with a 1 minus cos squared. So my sum becomes 3 times 1 minus cos squared theta plus 5 cos theta is equal to 1. Simplifying, 3 minus 3 cos squared theta plus 5 cos theta is equal to 1. So 0 will equal 3 cos squared theta minus 5 cos theta. 1 minus 3 gives me a minus 2. 3k squared minus 5k minus 2 equals 0. So I'm going to factorize that quadratic equation. My bracket becomes 3 cos theta, with a cos theta over here. And when I multiply out, I want to land up there with a minus 5 cos theta. My signs in the brackets are going to be different. So I want that to be the 2. So I land up here with a minus 6 cos theta and a plus 1 cos theta. Each factor in turn is 0. So here cos theta will equal minus 1/3. Here cos theta will equal 2. When I work out arc cos of minus 1 divided by 3, my answer becomes plus minus 109,5 plus k360. And on this side, if you try and work out arc cos of 2, remember, you're going to get no solution. Now in this sum, I added a restriction. So you always start off with your general solution, but now we've got to substitute various values of k and work out which values of theta are going to lie in the interval from minus 180 up to 180 degrees. So now if k is equal to 0, I get 109,5. 109,5 fits in my required interval. If I add 360, my angle is clearly too big. If I take my 109,5 and I subtract 360 degrees, my angle is minus 250, which is clearly too small. Taking the general solution minus 109,5, I can get an answer of minus 109,5, and again, adding or subtracting 360 is not going to give me another solution. So those are the only two answers that satisfy that equation and that restriction. This example over here, sine of an angle equals cos of a different angle. Here your angles were the same, okay? So I could get a quadratic equation in terms of cos theta, but the difference here is that my angles are not the same. So here I'm going to use my cofunction and my complementary angle. Doesn't matter which one you change, but here, for example, if I leave this as sine of 2 theta minus 10, cos of theta, cofunction sine, complementary angle 90 minus theta. And if sine of this equals sine of that, I can arc sine, and I get the answer that 2 theta minus 10 is going to equal 90 minus theta plus K360, or 2 theta minus 10 is going to equal 180 minus 90 minus theta plus K360. In each of these equations, we have to get the theta by itself. 2 theta plus theta is going to give me a 3 theta. 90 plus 10 is going to give me 100 plus K360. I'm going to divide through by that 3. 100 divided by 3 is going to give me 33,3 recurring, plus K times 120. On this side over here, this becomes 2 theta minus 10. Let me just do that so it's clearer. 2 theta minus 10. 180 minus 90 is going to be 90 minus theta plus K360. Sorry, minus a minus makes that a plus. My apologies. To take that theta across to this side, I'm going to get that theta is equal to 90 plus 10 plus K360. In this case, I only asked for the general solution, so K is going to be an element again of the set of integers. Example 4 is also going to use your cofunction and complementary angle. The only additional complication here is the fact we've got a minus sine 2 theta. Remember the reduction formula that says that sine of a negative angle, okay, so sine of, let's say, minus A is equal to what quadrant fourth, what sine negative, what axis x, what ratio, it stays the same. So sine of negative A is equal to minus sine A. I'm going to use that reduction formula here to write cos of theta plus 20 is equal to sine of minus 2 theta. Please notice it's really important that the minus is in front of the sine and not the cos. Because remember, your reduction formula for cos of minus angle A, what quadrant fourth, what sine positive, what axis x, what ratio, it stays the same. So you cannot, if you're solving an equation like this, you cannot work with that minus in front of the cos. You need to put it there so that you can make use of that reduction formula. Now I'm going to use again my co-function and complementary angle. This time I'm going to change both sides to cos. So we get that cos of theta plus 20 is going to equal co-function cos complementary angle 90 minus 2 theta. You might in fact have just noticed that you could have said cos of 90 plus 2 theta is going to be minus sine 2 theta, and that's also fine. Here we get that theta plus 20 is going to equal plus or minus this angle 90 plus 2 theta plus K360. We need to solve this equation for theta, so we're going to have to write it out twice. So theta plus 20 will equal 90 plus 2 theta plus K360, or theta plus 20 will equal minus 90 minus 2 theta plus K360. Theta minus 2 theta minus theta will equal 90 minus 20, 70 plus K360. So theta will equal minus 70 minus K360. It doesn't really matter whether you write plus K360 or minus K360 because K is an integer and it runs through all the positive and the negative numbers. On this side, minus 2 theta plus theta, you take it across, we get 3 theta is equal to minus 90 minus 20, minus 110 plus K360. Divide both sides by 3, so theta is going to equal 110 divided by 3, which is going to be 36,6 recurring plus K120, again where K is an element of the set of integers.